Okay, so here's from the 2018 exam 2. Frank owns a tennis court. A diagram of his tennis court is shown below. Assuming all intersecting lines, that means lines that cross, meet at right angles. So Frank stands at point A. Another point on the court is labelled point B. So you can see he's there, point B is there. What is the straight line distance, so the distance between the 2 points in a straight line between A and B? Round your answer to 1 decimal place. So you can see here we have a lovely right angle triangle. So let's use some Pythagoras theorem. So AB, that distance squared, is equal to 4.1 squared plus, now this distance here is those three, so 6.4 plus 6.4 plus 5.5 squared. Okay, so let's get our CAS. So 4.1 squared plus 6.4 plus 5.5, all of that squared. Enter. Okay, so we've got to find the square root of that. Right, so control that, bring up the square root, arrow up to grab that, press enter, hit enter again. Okay, so that is, so AB is equal to 18.7537. Right, we go back to our problem and it's set to 1 decimal place. So that means AB is equal to 18.8 meters. So Frank hits a ball when it is at height 2.5 meters directly above point A. Assume that the ball travels in a straight line to the ground at point B. What is the straight line distance in meters that the ball travels? Round your answer to the nearest whole number. So let's draw a little diagram of what happens there. Okay, so he's at point A, it's 2.5 meters above the ground. We've got B there. We know that distance AB is 18.8. So we want to find that distance x. Again, it's a Pythagoras theorem question. Oh, by the way, part A, 73% of the state got 1 mark there. So here, again, that distance x squared is equal to 2.5 squared plus 18.8 squared. So bring up my CAS again, 2.5 squared plus 18.8 squared. Enter. Then I need to find the square root of that one. Okay, enter. So that means x is equal to 18.9655. Okay, and it was to the nearest whole number, so that makes that 19 meters. So 19 meters. 60% of the state got 1 mark there. And if you got part A wrong and you got something different there, but you clearly used it in your workings and to get a correct answer, but obviously with that wrong information, there was a consequential mark there for you. All right, so Frank hits 2 balls from point A. For Frank's first hit, the ball strikes the ground, hits the ground at point P, which is 20.7 meters from point A. You can see it labelled there. For Frank's second hit, the ball strikes the ground at point Q. Now, we're not quite sure where Q is. Q is X meters from point A. Q is 10.4 meters from point P. The angle, PAQ, so that's the angle between P, A, and Q, wherever Q is 23.5 degrees. Determine 2 possible values for angle AQP. So that is the angle there. All right, I'll just undo that. So we don't know where P is. We don't know where P is. P could be, just a sec. Sorry, not P, Q. It could be here, or it could be here. We just don't know. All right. So this is that ambiguous case of sine. So it could be that angle, which is an acute angle, or that angle, which is the acute angle. As I say, we just don't know which it is. So what we have to do here is start to think about this. All right, so we know that point Q is 10.4 meters. No matter what, that side length there is 10.4 meters away. All right, so let's get out our sine rule. Now, the way we usually write it is with the distances on top. So that's that one there, and that's opposite our Q. So sine Q equals, all right, and we've got then that side, which is opposite that angle. So that is 10.4 over sine 23.5 degrees. Now you can flip this. If you understand fractions, you can flip those fractions to make life a little bit easier when we come to solving it. So sine Q over 20.7 equals sine 23.5 degrees over 10.4. Okay. So putting that into our calculator and things. So sine Q equals 20.7 times by sine 23.5 degrees over 10.4. Ugh. Thanks. Alrighty. 20.7 times by our fraction, which is sine 23.5, and I like to force it to degrees, over 10.4. All right, so that's what the sine q equals to. So I hit the trigonometry again to bring up my inverse sine, arrow up to grab that with enter. And then as it's in degrees, it should give you that decimal degrees of 52.5. So Q is equal to 52.5292. Okay. So as we don't know whether the angle is here inside the chord or here outside the chord, so it can be, you know, that acute or obtuse. We've got to, you know, think it can be either. So Q, let's actually have a pen. Q can equal to 52.5 degrees, or Q is equal to 180 take away 52.5 degrees, which gives you, so 180 take 52.5, 127.5 degrees. Now that was worth 1 mark. 25% of the state got that mark. 25% of the state got that mark. Now I do agree this is a harder question, but you know, in knowing that there's 2 potential answers there. So the second part of this, if point Q is within the boundary of the chord, what is the value of X? Round your answer to the nearest meter. So what is X? So X is the distance that Q is. Now, because it's within the boundary of the chord, we now know that it's this one, okay? Because that one, the acute angle, was outside the boundary of the chord. It was out. So this one was within the boundary of the chord. So it's in, and so that distance there. So that means we're using the obtuse angle. We're using that obtuse angle. So using my sine, I've got X over, using my sine rule, X over well, that angle there is what X is, and we can figure that out because we know that angle and that angle. All right, so 180 take 127.5 take 23.5 gives me 29 degrees. So that means X is over sine 29 degrees, and that then is equal to, well, that's the one, that's another one we can look at, or we can look at that one there. Let's look at that one there. So 10.4 over sine 23.5 degrees, and I want to work it out for X. So X is equal to sine 29 degrees times by 10.4 over sine 23.5. 5 degrees. Alrighty. So sine 29 degrees times by fraction 10.4 over sine 23.5 degrees. Control enter. So that means x is equal to 12.6446. And it's to the nearest meter. So that means x is equal to 13 meters. So 18% of the state got 1 mark there. So the key here really was that first calculation we made in making sure that that angle was correct. Okay, so when we found what that angle had to be, because obviously that angle is going to be different dependent on what that angle we use there at Q. Okay, so yeah, because we're wanting to find that distance x, which is opposite that angle there. So as I say, the ambiguous case is, higher level of this topic, but have a go, see how you understand it.